Hello, my name is Reed Eichley. Today I will be presenting my midterm project for EE201, Introduction into Digital Electronics. My midterm project for this is an alarm system for a radiological facility which would alert the workers in the event that an alarm in the room actuates, or if they were blocked in the room by one of two doors not being open. For this, my original design considerations were that if a radiological condition occurs, which would be alerted by a RAM, or a airborne contamination limit would be reached as indicated by a CAM, that an alarming condition would be sounded to alert all the workers in the area. Additionally, the workers would be required to have both doors open as a means of ingress and egress to the room, so an alarm condition would be set if only one out of the two doors were open. From this, I generated an original equation that an alarm would occur if the RAM or CAM or one of the doors were closed, and that is illustrated by A or B or C exclusive ORed with D. From this, it generated a truth table and figured out all the midterms for the alarming conditions. Using that truth table, I then put it into the K-map, and from there isolated and simplified the circuit down into essentially AND gates and OR gates that I could use to construct the circuit. Using multisim, I originally constructed the circuit just using the exclusive OR gate and the OR gates. I ended up using an additional OR gate since our lab kit did not have like a 3-input OR gate. So I cascaded the OR gates down since an OR gate will pass any high condition, and then finally tied that in with the exclusive OR gate. I used a 510 ohm resistor tied to an LED like we have been in previous labs. That way, when I tested the conditions, if an alarm occurs, the LED will light up, and if the alarm condition clears, then the LED would turn off. Since I had that original one, I tested it with the truth table, and it worked correctly. I then substituted all the components with NAND gates and NOR gates. I ended up using more NOR gates because once again the lab kit was limited on the amount of quantity of NAND gates that we had. So I started off originally with NAND gates, and then once I ran out of NAND gates, switched over to NOR gates since both are universal gates and both can be configured to all the other gates. I still kept the same output configuration and once again tested my final circuit in multisim to make sure that the truth table still holded true. I then took it and wired everything together on the proto board using NAND gate IC chips and NOR gate IC chips. As you can see, it kind of becomes a little bit of a convoluted mess just due to having to tie everything together and then additionally jumper down to tie the inverters for the exclusive OR gate inputs back into the exclusive OR gates, which the color coding of the wires did help somewhat in keeping track of what was what, but there was many times when I had to pause to think about and kind of write up like what is going where and what is the ultimate function that I'm having this chip perform, be it the OR functions or is it building into the exclusive OR functions. There was a couple hiccups along the way because the NAND gates and the NOR gates are not configured in the same sort of configuration, what are normally the inputs to a NAND gate as far as pin settings are some of the outputs of the NOR gates, so they're flip-flopped. So going back and forth through the data sheets for the IC chips and making sure that that was working correctly was very important. But once I did that, I connected it back up to the computer and using NI Elvis once again tested it against the truth table, and the truth table and my circuit matched. And that is the conclusion of my presentation. Thank you very much for watching, and if you have any comments, please email me at my UND website.